Okay, it's 1 o'clock. Good afternoon, and welcome to today's coffee lecture about DataWarrior. My name is Emmanuel Meyer, and I'm working in the Information Center, Chemistry, Biology, Pharmacy at ETH Zurich. So I'd like to give you a brief introduction to DataWarrior, which is a data visualization and analysis software. You can see here a few on the slide, a few plots, which you can generate starting from a spreadsheet, a kind of Excel type spreadsheet with molecules attached to it. So after a brief introduction, I'd like to tell you how to install the software, and then we will go for a brief demo. So DataWarrior is a very powerful open access software for data analysis and visualization, especially with data involving chemical structures, but not only. It has been developed and used for over 20 years at the pharmaceutical company Actelion and then Idorsia, and it's been released to the public in 2014. Now it's used in more than 150 countries and installed on more than 100,000 computers. And I've used this software for 20 years. So the features we're going to see today are a bit of data visualization and analysis with real-time data filtering. We will predict one molecular property from the chemical structure, but you can predict a lot. We will generate the 2D views, so scatter plots, pie charts, and a box plot, and also include statistical parameters. But DataWarrior is much more than these features. You can do machine learning using chemical descriptors, so PCA, SUM, t-SNE, plots, and UMAP. You can generate conformers and do energy minimization. You can do protein docking and interactive visualization, and all this can be, so the sequence of tasks can be recorded as a macro, and there is much more available. All this is summarized also on this link on this web page. So you can download the software at this web page, openmolecules.org. It's managed by the creator, by the developer of DataWarrior, Thomas Sander, former employee from Actelion and Idorsia in Basel. The software runs locally, and the generated files are saved on your own computer. The software itself is available as a Java source code free of charge. So there are three possibilities, either on a Linux, on a Mac machine, or a Windows. The installation is quite simple, so we don't do it here. What kind of data and files can be handled? So from an Excel sheet, you can save a CSV file. And if you're working with molecules, you should include the SMILES in it, SMILE strings. It can handle SD files, and it generates also its own data format DWAR files. Most important thing is to access the data, and where do you find this data? So today I'd like to show you one example where I access data from the supplementary information of a paper, but you can also go to Drug Bank, for example, and on the Open Molecules webpage, you can download a subset of Drug Bank and start to explore the chemical space. Directly from the software, you can access all the chemical structures from Wikipedia. That's also interesting. You can create your own data. So in an Excel file, one column with SMILES, one with biological activity or other properties, other numerical data associated with the compounds, or you can directly copy the SMILE from ChemDraw and paste it into DataWarrior. But this is a bit cumbersome. So the question we would like to ask, and this is a little case study, are amino oxytanes good replacement for amides in terms of lipophilicity? And this is a question which I took from this paper. It's a very recent paper from the group of James Ball, published in a JMedChem paper. And what they did is they compared oxytanes with amides And they looked at matched molecular pair analysis for a range of properties. And today we just look at the lipophilicity. So what was good is that they uploaded the CSV file as a supplementary information on the GMedChem homepage. So this is where I took the data. And with this data, we will do a scatter and box plot and a pie chart. So let's open DataWarrior, and I've opened it already. So the software is very powerful, a bit overwhelming at the beginning, but if you get used to it's quite straightforward. So you have different panels. On the left side, you see the traditional spreadsheet. This comes from your Excel sheet, and I've added from the paper the columns which were missing in the CSV file, the log-D values, and I added a comment. And then you see the structure view with all compounds, and you can see at the bottom that there are 42 compounds in the data set. There is a filter panel where you can start to filter properties or categories. So you have text filters, structure filters, and let's also add the lipophilicity as a slider filter. And now we have all the data with measured log-D. And this is a slider filter. On the bottom, you see the 2D view and the 3D view. And if you hover over a particular field, you see the information of the compound at the bottom right. So now to analyze the data, we need to segregate the data into different sets. So we'd like to see, because we make a comparison between oxetane and amide, we'd like to see which compounds have an oxetane in it. So I do a structure filtering, and now we see 10 compounds have this oxetane moiety. Let's create a subset. Let's create from this visible rows a subset called oxetanes. The other one, so I reverse the selection. I create a set with the amides. And you see that now you have a list membership. You have the amides, 10 compounds, the oxetane, 10 compounds. And all the others, they don't have a measured log-D, so we keep this away. So they don't have a log-D. And these are 22 compounds. So these are included in the Excel file that have been used for other calculation, other analysis. So I add here a third subset called others. And we need this for the visualization. Okay, now let's go to the 2D view. So we have 42 compounds still in the visible set. We would like to highlight the color according, I have to add a column called create a column with the membership, list membership. Now you see that every compound has its associated subset in the spreadsheet. And now we can start the analysis. Sorry. So we will set as the color according to the list membership, and we select a preferred. And here, so I selected in the settings the pie chart. We have the 3 lists, we have defined the 3 subsets, and now we have a pie chart. This is very well known in Excel, very easy to do. The beauty here that you can explore this pie chart and see the individual molecules. So you can hover, that's interactive real-time filtering or real-time visualization of molecular data. So that's the first chart I want to show. So now we want to calculate the properties. We will calculate from the chemical structure the log P and see how it correlates with the measured log D. So here you see you can do a lot of calculations. So today we just look at the C log P. And now we have an additional row, a column with the C log P, the calculated log P. Let's change so we want to measure, to correlate X being the C log P, Y being the log D. And we change the graph as a scatter plot. And here you have the correlation log P, C log P versus measured log D. With the two subset, every point is a molecule and you can hover above the data point and make sub-selection like this and work with this data. So let's include some statistical analysis. We go to statistical view options. We want to have a Brevet Pearson linear correlation, fit the line, and display the standard deviation. And here you have your statistical analysis. And you can see, do the amide or the oxytanes correlate better between C log P or log D? You can click. The R value is 0.788 for the amides, and for the oxytanes, it's 0.9. So that's how you can zoom in and analyze the data, which are all connected with the chemical structure. Finally, let's go to the third chart, which is a box plot. Here, so I set the preferred chart type, the box plot. So here we want to have the log D and the list membership. So we compare amides with oxetane. In 1 or 2 clicks, we got the box plot. Let's include some statistics. We want to show the median and the mean value. So the red line is the mean value, the black line, the median. And here you can see directly the difference between the mean log D of oxetane, which is 1.67, and here it's 1.60. For the amides, the difference is 0.07. It's exactly the number reported by the paper. So in a few clicks, you can really analyze chemical data and as in Excel, but connected with chemical structure, go further. So that's all for today. For the a brief introduction for this powerful software, here you would need to save what you did as a DWAR file or as a SD file. And you see there are a lot of possibilities. Access to Wikipedia, as I said, also Campbell is accessible, crystallography database, but this would be for another coffee lecture. Let's go back to the PowerPoint. I show you. So in the chat, I've added the link to the resources on Polybox. There is an original publication, a review, manuals, and forum on openmolecules.org. And then there are a series of very good webinars, long videos by different people not connected directly with the software, so not from the developer, and also workshop from somebody working at Idorsia. With that, there is a coffee lecture card in Polybox in the link I've given you. I thank you for your attention, and tomorrow we'll have the next coffee lecture on circos. Thank you very much. I'm happy to answer any questions.